In this chapter, we've been mostly talking about equations, but now we're going to talk about inequalities, which are like equations, except instead of an equal sign where something is equal to something else, we have either a less than, or a greater than, or a less than or equal to, or a greater than or equal to sign. And to give you an example of why we might want to work with inequalities instead of equations, well, do you remember this example from a while back? Melvin's taking a class. He needs to get an overall average of 90 to get an A for the class. And so we set up our equation and we solved it. But really, to get an A, he doesn't have to get exactly 90. He just has to get 90 or more. So it's not really a matter of being equal to a particular number. It's a matter of being greater than or equal to that number. He has to get an overall average of at least 90 to get an A for the course. So we could set it up as an inequality where his overall average, and remember that's 1/4 of the midterm score plus 1/2 of the research paper score plus 1/4 of the final exam score, where that is greater than or equal to 90. And then it turns out that for that to happen, x has to be greater than or equal to 100. So it's okay if his final exam score is 100. It's also okay if it's greater than that. Can it be greater than 100? Well, maybe if there's bonus points possible. Here's another example. Let's say you're going out to dinner and a movie by yourself, just to make the problem less complicated. I'm not saying you don't have any friends or anybody to go out with. We're just saying you're going out by yourself and you have $23 with you, and you know the movie ticket is going to cost you $8. How much can you afford to spend on dinner? So what you spend on the movie plus what you spend on dinner has to be less than or equal to the $23 that you have available. You don't have to spend all $23. You could, or you could just spend less than that. And turns out that means that the amount you spend on dinner has to be less than or equal to $15. But it could be all $23 that you spend, could be less than that, just can't be any more than that. Here are some other inequalities and ways they could be described in words. If we write x is less than or equal to 5, we could say it just like that. X is less than or equal to 5. I could say x is 5 or less. I could say x is no more than 5. That means the same thing. Might be 5, might be less than that, but it's no more than 5. Another way to say it would be x is at most 5. 5 is the most that x could be. Can't be any more than that. Jennifer will spend no more than $5 for lunch. That means that the amount that she will spend is less than or equal to, just no more than, 5. How about this one? Y is greater than or equal to 18. We could say it like that. We could say y is 18 or more. Could say y is at least 18. At least 18 means might be 18, might be more than that, but can't be any less. You must be 18 or over. That means your age has to be greater than or equal to 18. If you're 18, that's okay. If you're 21, that's okay. If you're 92, that's okay. It just has to be greater than or equal to 18. And here are some examples where we have to be between two numbers. The food should be kept between 32 and 40 degrees Fahrenheit. One way to write that would be like this. 32 is less than x is less than 40. So that's saying that 32 is less than 40. You got 32 on the small end and 40 on the big end, and x is somewhere in between. If you look at that from x's point of view, x, that's the temperature of the food, has to be on the big side of 32 and on the small side of 40, so somewhere in between. 33 would work. 37 would work. Anything would work as long as it's greater than 32 and less than 40. So we could say it like that. X is greater than 32 and X is less than 40. Or we could just run it all together like this. The children at this camp are at least 9 and no more than 13 years old. If they're at least 9, that means their age is greater than or equal to 9. If they're no more than 13, that means their age is less than or equal to 13. So we could write it like that. A is greater than or equal to 9 and A is less than or equal to 13. Or we could put the A between the 9 and the 13. 9 is less than or equal to A is less than or equal to 13. So the age here is between the 9 and the 13. Greater than or equal to 9, less than or equal to 13. You get a B if your score is 80 or more, but less than 90. So that means your score has to be greater than or equal to 80 and less than 90. It has to be between 80 and 90, possibly equal to 80, or possibly greater, but definitely less than 90. So there's more than one way of writing the same thing. Here's some examples of things that mean the same thing. 7 is greater than X means the same as X is less than 7. Either way, X is on the small side and 7 is on the big side. So X could stand for any number over here on the small side of 7. Could be 6, could be 0, could be negative 10, could be something like 6.5 or 6.9. But can't be 7, can't be anything bigger than 7. X has to be any of these numbers that are less than 7. We can show it on the number line like this, and we can show it in interval notation as the interval from negative infinity to 7. 4 is less than X means the same thing as X is greater than 4. Either way, X is on the big side of 4. So X is any of these numbers over here to the right of 4 on the number line. And we can say that's the interval from 4 to infinity. 10 is less than or equal to X means the same as X is greater than or equal to 10. And I got that backwards, didn't I? There, I fixed it. X is on the big side of 10. So X could equal 10. It says X is greater than or equal to 10. So we're including 10 as well as all the numbers that are greater than 10, like 11 or 12 or a million. So that would be the interval from 10 to infinity. And notice I've got a square bracket by the 10 in the interval notation and also in the graph. And that's to show that 10 is included. We are including the number 10 as one of the things that X could equal. And how about this? 2 is less than X is less than or equal to 5. So X is greater than 2 on the big side of 2 and less than or equal to 5. So these are the numbers that X could be. It can't be 2, but it can be anything even a little bit bigger than 2 as long as you're less than or equal to 5. So anything between 2 and 5, not including 2, but including 5. We can show that in interval notation like this, 2, 5, with a round parenthesis by the 2 and a square bracket by the 5. So notice how that interval notation works. It's always something, something else. And we always go from left to right or smallest to largest. So the first thing is always smaller than the second thing. And we always have either a round parenthesis if that thing is not included, or a square bracket if it is included as one of the numbers X could be equal to. If we go forever to the right, we put an infinity sign there. And if we go forever to the left, we start with a negative infinity. So let's practice this. In these examples, look at what's showing on the number line and express it in interval notation and also as an inequality involving x. So it's real easy to translate from a graph to interval notation. Always look at where you start and where you end. So here we start at -3 and we go over until we get to 6. So this would be the interval from 3 to 6. And we use square brackets just like what shows on the graph. We call that a closed interval. It includes the -3 and the 6 as well as all the numbers in between. So we can write it like this. X is between -3 and 6. So we got -3 less than or equal to x less than or equal to 6. How about this one? This would be the interval from 1 to 9. This time we have the round parentheses to show that we're not including the 1 or the 9, just all the numbers strictly in between. We call this an open interval, the open interval from 1 to 9. And we can write this as x being strictly between 1 and 9. 1 is less than x is less than 9. How about this? This would be the interval from -3 to infinity, with a round parenthesis by the -3, and then there's always going to be a round parenthesis by the infinity sign, because infinity isn't a number that x could be equal to, it's just a symbol meaning forever off in that direction. So this would be x is anything greater than -3. All the numbers greater than -3. What about this? This is the interval from what to what? Well, from -infinity to 2, with a square bracket by the 2, because that's what's showing on the graph, and a round parenthesis by the -infinity symbol. X can equal 2 or anything less than 2. So this would be x is less than or equal to 2. Now let's start with the inequality using x and illustrate it using the real number line and write it in interval notation. And I think it's probably easier to start by drawing it on the number line, and then by looking at that we can get an idea of what the interval notation should be. So where are the x's that are greater than 9 on the number line? That would be everything over here to the right of 9. I'm showing that 9 itself is not included by putting this round parenthesis thing there. So we're not including 9, but we are including anything that's even a little tiny bit bigger than 9, like 9.01. And so this would be the interval from 9 to infinity with the round parentheses. What about this? X is less than or equal to 4. So here's 4. The numbers that are less than 4 would be everything over here to the left of 4. And we are including 4. X could be less than or equal to 4. So we show that with a square bracket looking thing on the graph. And this would be the interval from -infinity to 4 with a square bracket by the 4. How about -2 is less than or equal to x is less than 6. So x is between -2 and 6, on the big side of 2 but on the small side of 6, and it could be equal to -2. So we are including the -2 but not the 6. We show that on the graph with a square bracket by the -2, a round parenthesis by the 6, and then we shade in what's between, and we also need the square bracket by the -2 and the round parenthesis by the 6 in the interval notation. It's the interval from -2 to 6. We start at -2 and we are including that because x could be equal to -2. And then we're going up until we get to 6, and we're not including that, just all the numbers that are even a tiny bit less than 6. So that's a half open interval. It's not closed with square brackets on both sides. It's not open. It's half open.